There's a lot we know about the universe, from star systems to dark matter and dark energy. Decades of research and observations have helped us understand how the universe formed and grew. However, a recent shocking discovery by the James Webb Space Telescope has left scientists scratching their heads. This discovery shatters the current standard model of our universe's evolution and even breaks one of the fundamental laws of physics. What is this discovery and why is it so dire? What does this mean for our cosmic model and the scientific community? Join us in this video as the James Webb Telescope image just shattered our cosmology into pieces. Understanding the universe's evolution has always been of primal importance to mankind. The desire to learn how the vast world around us came to be spurred the birth of disciplines like astronomy and cosmology. Thanks to these fields of study, we've learned much about the vast world of space and its many cosmic wonders. For instance, we've learned that the universe isn't evenly spread out. Some areas are more dense than others. This is one thing that makes scientists believe in the Big Bang Theory. The Big Bang Theory is the well-known, universally approved theory of how life began in the universe. The theory states that the universe started as a single-point explosion before expanding and cooling to grow into what it is today. Several things, including the cosmic microwave background, CMB, seem to support this theory. The CMB is the remnant of the first light emitted after the universe's birth. Think of the CMB as the afterglow from the Big Bang. The light has existed for over 13.8 billion years since the conception of the universe, carrying with it information from the early universe. Theories that define the universe's evolution have evolved dramatically over the years. This is because newer discoveries are made as more sophisticated instruments are introduced into the research process. These discoveries prompt the need to adjust existing theories or create new ones altogether. However, it becomes mind-boggling when sudden unexplainable events take place in the universe. In the twinkle of an eye, such events make the scientific community wonder if there's a magical force at play in the universe or if we had it all wrong from the start. The James Webb Telescope discovered one such event. As you well know, the James Webb Telescope has been the revolutionary telescope of 21st century cosmology. The phenomenal instrument has not only given us clear images of the space beyond our planet, but has also allowed us to peer deeper into the cosmos than ever before. James Webb was created to observe the universe like never before. It was intended to observe the farthest parts of the cosmos to seek out stars and galaxies formed moments after the Big Bang. Studying such stars would help further understand how stars and planets have evolved and give insights on how to improve or expand on the Big Bang Theory. By studying the universe with sophisticated scientific instruments, scientists were able to discover and introduce other concepts like dark matter, dark energy, and the expansion of the universe. All of these are concepts and phenomena that support the Big Bang Theory. For instance, the theory of universal expansion depicts that the universe is constantly expanding. This means that galaxies and galaxy clusters are constantly drifting farther and farther away from each other. It's believed that this has been the case ever since the birth of the universe 13 billion years ago. As the universe expands, more and more stars and galaxies are born. Scientists believe that the mysterious force behind this expansion is dark energy. They also think there is invisible matter in the universe called dark matter. Over the years, several methods have been introduced to measure or detect dark matter in the universe, but no true methods have emerged. The JWST, however, gives scientists an edge. Via its deep images, astronomers can use the images to calculate how much dark matter is present in a specific part of the cosmos. Gravitational lensing also helps in this process. Gravitational lensing is a phenomenon that describes how massive objects in the cosmos warp the space around them, resulting in the bending of light as it passes by them. Galaxies and galaxy clusters are known to cause extreme warping of spacetime, causing light from a distant source to bend. By observing the effects of gravitational lensing in JWST images, scientists are able to map the distribution of dark matter in the universe. So you can see how much of a pivotal asset the JWST has been to humanity. Without it, we would have never been able to bring life to many of the foundational theories of the cosmos. More so, we'd never have the beautiful image of distant stars and galaxies like we do today. Yet, as much as it has been very helpful to the scientific community, James Webb isn't relenting in its efforts. Recently, James Webb has made a couple of impressive discoveries. One such discovery is the planet-like objects captured in the Orion Nebula. The Orion Nebula is a popular nebula in the Milky Way. It is depicted as the sword in the Orion constellation. Prior studies of this cosmic cloud of dust and gas never revealed any objects hidden in its chambers, but that was until the JWST came along. This is just one of the many recent interesting discoveries the JWST has unleashed. Now there's another discovery that isn't only interesting but very disturbing. This recent discovery, as depicted in JWST images, can shatter our entire background of cosmology. In fact, scientists are beginning to think the Big Bang Theory might be wrong. But what did James Webb really discover? And why is this discovery shaking our entire foundation of cosmology and astronomy? Well, recently James Webb revealed that over 771 trillion solar systems have suddenly vanished from our universe. This means that over 771 trillion stars and their associated planets have disappeared. This is not normal. In fact, this has never been witnessed before. Moreover, this event goes against one of the very fundamental laws of physics, the law of conservation of matter. This law states that mass can neither be created nor destroyed, but can be transformed from one form to another. Given that the study of the universe so far is based on laws such as this, scientists find it hard to explain how an entire world of stars and planets disappeared from the universe. Were they destroyed, or did they just shrink out of sight? Some experts have come up with a plausible theory. One such theory postulates that the disappearance of these solar systems is actually a final stage in the transformation of their mass. In other words, these stars and planets still exist in the cosmos, just in another form we can't see. This theory follows the events of stars when stars get old and can no longer hold the gases in. They explode, a term we call supernovas. As the star explodes, all of its mass is scattered into the universe in the form of tiny particles. What if something similar happened to these solar systems that suddenly disappeared? While it may be possible, most of the scientific community does not agree. You see, stars do not just disappear without at least a supernova, and there's no way a massive supernova involving trillions of stars would go unnoticed. Such a colossal event would have echoed through the entire universe, and even our Milky Way galaxy would suffer the ripple effects. So this first theory is being pushed aside. However, another theory has brought a different light to the situation. This theory suggests that black holes may be responsible for the sudden disappearance of these stars. Black holes are strange high-gravity regions in space that suck up matter, light, or anything that dares to get close. Black holes have sometimes been spotted swallowing entire stars, eating them alive. But then, in this scenario, the theory of black holes being responsible doesn't seem very logical. As we mentioned, we're talking about trillions of stars here. Can one black hole swallow a trillion stars? Not likely. Unless there were millions of black holes, there's no sense in saying black holes were behind this mysterious event. The mystery of this event has forced a team of scientists to turn their attention to the history books. One scientist, Beatrice Villo from the Northern Institute for Theoretical Physics in Sweden, has spearheaded a unique project that hopes to solve this mystery. This project, called VESA, involves scanning the astronomical archives to find a star that has existed in the night sky since the dawn of cosmology, but suddenly disappeared sometime in history. In other words, she and her team hope to find a star that ended up exactly like the 771 trillion star systems. If such a star is found, scientists could decipher why it vanished and use that to explain why this is happening now. However, so far, no such star has been found. Be that as it may, the VESA project has still sparked phenomenal interest from astronomers, experts, and researchers in various fields. Some of these experts believe that there might have been a star that disappeared from the skies above, but due to the vastness of the universe, such a star may have gone unnoticed. So maybe the very star that would have been used as a case study for this project was never even catalogued in the first place. However, Villo and her team of experts aren't giving up on the VESA project just yet. There's a chance that a star had vanished from our skies unnoticed. Moreover, one astronomer named Leah Aravi suggested that certain stars may possess the ability to die without going through the usual process of supernovas. These stars can simply undergo a direct transition from their dying phase to become black holes. Leah mentioned a scenario in 2009 when a star that had been identified to be at the end of its life cycle suddenly exploded and transformed into a black hole. The entire event happened so fast that scientists couldn't even grab details of the process. Could such a scenario be repeating itself here? Well, considering that the JWST didn't spot any black holes in place of these star systems, it seems unlikely. Data from the JWST revealed that stars just vanished without leaving a trace. In the end, this entire discovery has left the scientific community quite disturbed. This is because it brings about a severe challenge to the current understanding of cosmology. For the most part, the current belief is that the universe is expanding. This means that new stars and galaxies are being formed as old ones die and scatter into the universe. But what if the universe is not expanding at all? Or what if it's just a front for something bigger? If we were to look at these 771 trillion stars and solar systems as a real phenomenon, then it would mean that something else might be wrong with our understanding of the universe. In conclusion, this discovery presents a scientific crisis and has left researchers with numerous questions about the universe's future. The JWST has once again shown that there's more to discover in the cosmos. It challenges old ideas and pushes us to redefine our understanding of the universe. Only time will tell what new theories will emerge from this extraordinary discovery and how it will reshape our view of the cosmos. Stay tuned as we continue to explore and understand the mysteries of our universe. The implications of this groundbreaking discovery extend beyond just a reevaluation of cosmological theories. It compels scientists to rethink fundamental principles about the nature of cosmic phenomena and the laws governing them. For instance, the sudden disappearance of these 771 trillion solar systems may prompt a reassessment of how matter and energy interact on a cosmic scale. This could lead to new hypotheses about the life cycle of celestial objects and the nature of their ultimate fate. One intriguing avenue of exploration is the possibility of unknown cosmic processes or entities influencing the disappearance of these stars. For instance, some scientists are speculating about the role of hypothetical constructs like dark stars or strange matter. Dark stars, a theoretical concept, might be objects with an unusually high density of dark matter. Such stars could potentially have different life cycles compared to ordinary stars, possibly explaining their sudden vanishing. Similarly, strange matter, which is theorized to exist in extreme conditions, might have unique interactions with regular matter that could cause such phenomena. Moreover, this discovery opens up new questions about the structure and composition of the universe. If large numbers of solar systems can vanish without a trace, it suggests that our current understanding of cosmic inventory might be incomplete. This might necessitate the development of advanced observational techniques and more refined theoretical models to account for such discrepancies. Future missions and telescopes, perhaps even more advanced than the JWST, might be required to probe deeper into these mysteries and provide more comprehensive data. The discovery also has philosophical and existential implications. The sudden disappearance of such a vast number of stars challenges our perception of the stability and permanence of the universe. It raises profound questions about the nature of existence and our place in the cosmos. If the universe is capable of such dramatic and unexplained events, it might prompt a re-evaluation of humanity's role and future in this ever-changing universe. In addition, this anomaly could have practical implications for future space exploration and technology development. Understanding why and how such a vast number of solar systems disappeared could influence the design of new missions, the types of instruments developed, and the strategies used for exploring distant regions of space. It may also impact how we approach the search for extraterrestrial life, as the conditions necessary for life might be influenced by these cosmic processes. In summary, the recent discovery by the James Webb Space Telescope has far-reaching consequences that extend well beyond the immediate scientific community. It challenges existing theories, invites new hypotheses, and calls for a deeper investigation into the fundamental nature of the universe. As researchers continue to explore this enigma, the potential for groundbreaking discoveries and new insights into the cosmos remains vast and exciting.